For example, if you want to draw the graph of y is equal to x square minus 1 by x square plus 1. So quickly you try to categorize the nature of this function. So this is a rational function, polynomial by polynomial. So for rational functions, usually we start with Wavy curve analysis. So first, if you look at the zeros, that is the points where the numerator is equal to 0, that is the points where y is equal to 0, that is the points where the curve meets x-axis. So the critical points are x is equal to 1 or minus 1, right? X square is equal to 1 implies x is equal to 1 or minus 1. And x square plus 1 is never equal to 0. So the domain of this is all real numbers. The domain of this function is all real numbers. So at the first stage, I'll draw the wavy curve for this. So in wavy curve, the critical points are 1 and minus 1. The leading coefficients of both the highest powers, both numerator and denominator, are positive. So the curve starts from here. And x square minus 1 is x plus 1 into x minus 1 by x square plus 1. So corresponding to each of these critical points, the power is odd. So the sign change happens. So this is the wavy curve. This is the wavy curve for this. So now one stage of the graph is completed. Next stage is, let us try to understand what happens at x is equal to plus or minus infinity. So as x tends to plus or minus infinity, where does y go? That is, limit x tends to infinity, x square minus 1 by x square plus 1. So in limits we have seen that as x tends to infinity, only the highest powers matter. So this minus 1 and plus 1 can be neglected. X square by x square is equal to 1. Limit x tends to minus infinity, also the same thing happens. This limit is equal to 1. That is, as x goes to plus or minus infinity, the value of y tends to 1. That is, you get a horizontal asymptote. So the graph will be something like this. This is 1, this is minus 1. Assume that this is the line, y is equal to 1. As x goes to infinity, the value of y tends to 1. So the graph will be something like this. Graph will be something like this. Again, you might get it out. So we have just proved that as x tends to infinity, it goes to 1. So you might feel that why should it go straightly to 1? It can go up and then go to 1. Here also it can go up and then go to 1. It is also possible. So now we just know that as x tends to infinity, the value of y goes to 1. So if you are interested also in how it goes, does it go straightly, directly, or does it go up, come down and go? So if you have this doubt, so you have to go for maximum minimum analysis. So if you go for maximum minimum analysis, dy by dx is equal to x square plus 1 whole square, x square plus 1 times 2x minus x square minus 1 times 2x is equal to 0. 2x times 2 is equal to 0. This implies x is equal to 0. That means the curve has a stationary point only at x is equal to 0. So if it goes up and come down, here also you should have a stationary point. But from the differentiation, we found that only x equal to 0 is a stationary point. Hence, there should not be any other stationary point. That means the graph is going straightly to 1 here, straightly to 1 here. So this will be the required graph of the function x square minus 1 by x square plus 1. So if you want the exact values here, we know that at x is equal to 0, you have a stationary point. From the graph, it's very clear that it has to be a minimum, it cannot be a maximum. So what is the minimum value? If you put x equal to 0, you're getting minus 1. The graph is going to minus 1. And once you draw the graph, you can also find the range very easily. So what is the range of this? Closed minus 1 to open 1, because it is asymptotically going to 1. So it will never be equal to 1. So once you understand curve sketching, the range finding becomes very easy.